Okay, so good morning, you guys. I hope you're doing well. Listen, today we're going to have a lesson on exponents. So I know that I made you write out the laws of exponents, the rules of exponents, but I honestly think that it's a lot easier if I'm explaining it to you step by step, and we're kind of to figure out kind of why the rules apply. So let's look at a few examples. Let's look at x to the fourth power times x to the sixth power. Okay, now we might know how to do this already, but let's just kind of look at why it's the way that it is. So let's look at x to the fourth power. So remember, anything to a power is that thing, that base times itself that many times. So here we're gonna go x times x times x times x, right? Because that's 4 times, right? And now we're gonna say times, and then we're gonna do x to the sixth power. So we're gonna say 1, 2, 3, 4, 5, 6, okay? So when in doubt, we're gonna write it out. We're gonna always write it out to see that we understand. So we know that there is a invisible 1 for all of these x's. So if we were to write all those out, then we know all together we have x, and if we were to add all of those 1s, we get x to the 10th power, right? So when the bases are the same, you just add the exponents. You keep the base the same, and you add the exponent. So let's look at x to the sixth power over x to the fourth power. Okay, let's write it out. So on the top, we have 6 times. 1, 2, 3, 4, 5, 6 over. And then on the bottom, we have 4 times. 1, 2, 3, 4, right? We cross these out because we're simplifying. And on the top, we have x to the second power over 1, which just becomes x squared. That's our answer. So in this case, we had the base stay the same, so our x stayed the same, and we took 6 minus 4, and we got x equals 2. It's the same thing. I was just showing you why it's that way. So remember, we subtract the exponents. So let's look here. So let's say we have, well, x to the fourth power over x to the sixth power. So let's draw that one out. So 1, 2, 3, 4. And of course, you don't have to draw them out. I'm just showing you so that you'll understand why they look this way. Then we have 1, 2, 3, 4, 5, and 6, correct? So let's cross out. That crosses out, that crosses out, crosses out, crosses out. On the top, we're left with 1, right, over x squared. Well, that is your answer. But I want us to think about that for a second. So let's think about this is fine, but let's just say you were just solving it the way you know. You would just look at the base, and then you would subtract the exponent. So you would say 4 minus 6. Well, we know 4 minus 6 equals negative 2. So remember, whenever you have a negative exponent, you can't leave it that way. It's not simplified. So what do? Well, negative exponents move to the other end of the fraction and become positive exponents. So you kick it downstairs. So this becomes 1 over, kick it down, x squared. So it goes downstairs and it comes positive. So this is your answer. So really, your answer started out with x to the negative 2 power, and that equaled 1 over x squared. But I wanted you to understand why it's this answer. Okay, so let's look at another example. Okay, let's look at a harder one. Let's look at 27 x to the 27th power, okay, over 18 x to the 18th power. Well, the first thing I want you to do is just look at your variables. I'm sorry, not your variables, your coefficients. So we have 27 divided by 18. 27 divided by 18. Now let's look for our greatest common factor between 27 and 18. Well, we know it's 9, right? So 9 goes into 27 3 times, and it goes into 18 2 times, right? So we finished that part. Now, let's just make sure we have a fraction here. And now we have 27 minus 18. So remember, we take the top minus the bottom, and we get positive 9. So now we get x to the 9th, and it stays on top. That's your answer. So this is your answer. You would probably see it written like this, though. 3/2 x to the 9th. Okay? So that would be the way to write that. So let's look at another example. Let's say you have, all right, we have negative 3x squared, and that's all in parentheses, to the 4th power. Well, let's look at this. We're going to take negative 3 times negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 becomes positive 9. 9 times negative 3 becomes negative 27. Negative 27 times negative 3, right, becomes positive 81. So here we get positive 81, right? And now we're going to look at, so what we did was we just took negative 3 times negative 3 times negative 3 times negative 3. And then over here, we're just going to, remember the rule is now you're going to multiply these exponents. So now it's going to become 81x to the 8th power. Okay? So if you really want to understand that, we could say, well, first you started with this negative 3 and you took it 4 times. 1, 2, 3, 4. And you got positive 81. Then you took this x squared. So really what this looked like, it was really x squared times x squared times x squared times x squared, right? And so the base stayed the same and we added the exponent. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. That's how we got 81x to the 8th. So I hope that made sense. All right, and let's try a different one. Let's